let's say if you remember stuff from long time ago. Is that an equation of a line?
Yes.
Yes. In what form? Standard form, right? So this comes into play when we do system of linear equations, because in most cases we want the equations in standard form. But at the end of the day, when we find the solution, it is going to be a point of intersection of two lines. So suppose I have two linear equations. Both of them are linear equations because if I rewrite it from standard form to slope-intercept form, I'm just going to have a line. We call it a system because we have two lines. And specifically, this is a system in two unknowns. Unknowns in the sense two variables. So if you have a system with two unknowns, you will have to have, or you must have, two equations, or else you cannot solve them or solve for them. So I have two variables, x and y, which would simply imply that I would need two equations to solve, and I have two equations. Does that make sense? Okay. Now, there are a couple of ways to solve this. First is the substitution method. The next one is the elimination method. By all means, the elimination method is a generalization of substitution method. They are identical. If you kind of made a mistake, you could always verify your answer by graphing. So what does the solution mean for the graph? A linear equation represents a line. So we have two equations, which would imply that there are two lines. And when we find a solution, we are actually finding the point of intersection of the two lines. So how do we solve? We either use the substitution method or we use the elimination method. Any questions so far? Yes, no, thank you. Okay. I'm going to use the same example. I would like to check if 3, 1 is a solution to that. X is 3 and y is 2. And how do we check if something is a solution? You just take the value of x and y and plug it in the equation. So you have to check in both equations. That is something that people fail to do. So I'm going to start with the second equation. There's a reason for that. So at the point 3, 1. The value of x is 3. The value of y is 1. So x plus y equals 4. That is the equation that is provided to us. X is 3. Y is 1. 3 plus 1 is 4. Is 4 equal to 4? Yes. Oftentimes, students would just stop right here and say, oh, I found the solution. But if you go back and plug in 3, 1 in the second equation, x is 3 and y is 1. 2 times 3 is 6, and 6 plus 1 is 7. Is 7 equal to 3? No, right? So the point satisfies one solution, excuse me, one equation, but it doesn't satisfy the other equation. So 3, 1 is not a solution to that system. So I'm going to take 2, 2 and plug it in the first equation. So x plus 2y must be equal to 6. 2 plus 2 times 2. X is 2, y is 2. So 2 plus 4, I have 6 is equal to 6. So it is a solution. The next equation is 3x plus y equals 8. I plug in 2, 2, 3 times 2 plus 2. 3 times 2 is 6. 6 plus 2 is 8. 8 is equal to 8. That checks out too. So what we have is in fact a solution to the system. So here's a question. Where do the two lines intersect? At 2, 2. Because the solution is the point where the two lines intersect. Elimination method is a generalization of the substitution method. But let's start with this method. What does substitution mean? You simply take one of the equations and you substitute in the other for one variable. So first you choose a variable, and then you solve for that variable and take that, plug it in the other equation. There are some pitfalls to this approach. One, choosing the right variable. If the numbers are too large and you picked the wrong variable, you're just going to end up making lots of mistakes. Two, sometimes the equation might be complicated where you cannot substitute things properly. So that would also create an issue. So this problem though is straightforward. And if I asked you to pick one variable, which one would you pick? An easy variable.
The x.
The x? Why?
Because I mean, out of the top equation, it's like the first one.
Okay.
First.
It's alone.
It's alone. We can give company. 3 is giving company to x. Why not y? So I want to rewrite x, or I can rewrite y. In this problem, both x and y are easy choices, right? Because I don't have anything multiplied to them, in the sense they are alone, they are by themselves. So I'll pick y, take the second equation and rewrite it so that I get an equation for y by itself. So I'm going to move 3x to the other side. Y would be equal to 6 minus 3x. This is my substitution. I'm going to take that. And plug it in x plus 3y equals 10. So x plus 3 times y is 6 minus 3x. Plugging in for y. It is best to put it within parentheses or equal 10. Now we have to distribute and simplify. X, distribute the 3. 3 times 6 is 18. 3 times negative 3x is negative 9x. That would be equal to 10. What is x minus 9x? Negative 8x. I want to solve for x, so what should I do next? Subtract 18. What is 10 minus 18? Negative 8. Divide by negative 8 on both sides. I get x to be 1. Good. Now that you've found the value of x, you can take this and plug it in either the first equation or the second equation. Which one should we pick?
First equation.
First. So x is 1. So 1 plus 3y would be equal to 10. 3y, 10 minus 1, if you move the 1 to the other side, would equal 9. If 3y is equal to 9, what is y? Divide by 3 on both sides. What is 9 over 3?
3.
3. So the solution to this system is x is equal to 1 and y is equal to 3. You can go ahead and check if I did this right. So let's check if 1, 3 is in fact a solution to that system. So once again, you don't have to check if the point that you have is a solution with every problem. Once you have enough practice, build confidence, you don't have to do it. If I plug it in the first equation, one plus 3 times 1, sorry, 3 equals 10. 3 times 3 is 9. 9 plus 1 is 10. 10 equals 10. Works. Are we done yet? No. Try the other one also. When I plug in 1 for x, I have 3 times 1. Y is 3. 3 times 1 is 3, and 3 plus 3 would be 6. 6 is equal to 6. That works also, so I have the right solution. So the easier equation here is the second one, x plus y would be equal to 3, which would mean y is equal to 3 minus x. So we rewrote y in terms of x. Could I have written x in terms of y with the second equation? Yes, that is a matter of choice. I'm going to go with y. So take this and plug it in the first equation. Distribute the 3. 3 times 3 is
Not nine.
9. 3 times minus x is minus 3x. What is 2x minus 3x? Negative x plus 9 is equal to 7. We want to solve for x, so I'm going to move that 9 to the other side. Seven minus 9 is negative 2. The negatives will get cancelled. So the solution to x is 2. Here is another question. Got to substitute x is equal to 2 in one of the two equations to solve for y. Which one would you pick? The second one. It's easier because it looks like a simpler equation. So 2 plus y equals 3. Subtract 2 on both sides. Y would be equal to 3 minus 2, and y is equal to 1. Okay. Should we pick x? Should we pick y?
It doesn't matter.
In this problem, it doesn't matter. But which equation should you pick?
The second one?
The second one is easier. So I am going to pick y. If you pick x, that's perfectly fine. If I move the x to the other side, the substitution becomes y is equal to negative x. I'm going to take this and plug it in the other equation. Y, we've got to substitute negative x, so make sure you put parentheses. So x plus 2x minus times minus is plus. So 3x would be equal to 3. Divide by 3 on both sides. X is 1. Yes? Now take x and plug it in there. This substitution comes from that equation, so it doesn't matter where you plug it in. So y would be negative 1. Good. Are we clear? So, should you pick the first equation?
Yes.
Should you pick the second equation?
The first word.
The first one, relatively, the first one is easier because even though there is a fraction here, y is by itself, correct? So first equation is the way to go. The second equation has a number there, has a number there, so solving for y will be more complicated. That's what I can keep the first equation as is and proceed, or what's your name?
Johnny.
Janique mentioned could be converted to a decimal and then proceed. Sure, but it's not necessary. But this is what I would do. I'm going to get rid of the fraction by multiplying both sides by 2. Good. So 2 times 1/2 x plus y would be equal to 2 times 2. Correct? Distribute the 2 and the 2 will get cancelled. 2 times y is 2y, and 2 times 2 is 4. Good. Even after doing that, which is the easier equation? The first or the second?
So the first one.
Still the first one, because I can rewrite this equation in terms of y. X is by itself. So the golden rule of thumb is you always look for the variable that is lonely. Good. So you can save it. x would be equal to 4 minus 2y. Good. Take this expression, plug it in the first one, excuse me, the second one. X is equal to 4 minus 2y. I'm going to plug it in for x. Plus 3y equals 7. Distribute the 2. 2 times 4 is 8. 2 times negative 2y is negative 4y. Plus 3y equals 7. Move the 8 to the other side. Negative 4y plus 3y equals 7 minus 8. 7 minus 8 is negative 1. Negative 4y, positive 3y is negative y, which would imply y is negative 1. 1. Now we have to take that one and Adriana, right? Adriana asked me, well, does it matter whether to plug it in the original equation or the equation that we rewrote? No, it doesn't. If you think this would be easier, go for that. So y equals 1. In y half 1/2 x plus y equals 2. So 1/2 x plus 1 would equal to 2. Move the 1 to the other side. 1/2 x would be 2 minus 1. 2 minus 1 is 1. Multiply by 2 on both sides. X would be equal to 2. Good. You can plug it back in. It is going to verify it is the correct solution. So, of course, I could use substitution method to solve this system of equations, but I'm going to use elimination method. Just like the substitution method, you've got to ask as to which variable you intend to get rid of. Which one do we want to get rid of, x or y?
Second equation.
We all like to get rid of x. It's a bad joke. So which one would we use, x or y?
Y.
Y, okay. So I can eliminate y provided they are the same. In other words, I need to have a 2y there. So I'm going to write the first equation. X plus 2y equals 3. How do I get a 2 there? I can't just arbitrarily throw a 2. Multiply by 2 on both sides. 2 times 3x is 6x. 2 times y, 2y. 4 times 2, 8. Good. I am going to subtract. Now, here is some, yes.
Where did you get that 6x plus 2y?
Multiplying the second equation by 2 on both sides. So, can you see it? Yes. Here is another thing. Some students in the past I've seen, they want to multiply by -2 and add here. It really doesn't matter. I like to go with whatever operation that I do here, either addition or subtraction, as long as you eliminate the variable that you intend to get rid of. So I can get rid of it if I subtract it. So 2y and 2y would go away. x minus 6x is negative 5x. 3 minus 8 is negative 5, which would imply x is negative 1 or 1. Now, take this one and plug it in one of the two equations to find the other variable, y. Which one's easier? The top one. So 1 plus 2y would be equal to 3, which would imply 2y equals 3 minus 1, which is 2. Divide by 2 on both sides, I get 1. Good. Now that we have seen both methods, which is easier? Elimination or substitution? Elimination. And given substitution, elimination, and graphing is the easiest. Good. Okay, so we have 3x minus 4y equals 3, and x plus 2y equals 1. So which one do we want to eliminate, x or y? X, okay. So if I want to get rid of x, I need to multiply this equation by something so that I get 3x here. So what should I multiply by? 3. So I'm going to multiply the second equation by 3 on both sides. Good. Now back to the first equation, which is 3x minus 4y equals 3. To eliminate the x, what should I do? Should I subtract or add? Subtract. 3x and 3x will go away. 6x minus 4y would become 6x plus 4y, which is 10y. And what is 3 minus 3? 0. We solve for y, so we've got to divide by 10 on both sides. What is 0 divided by 10? 0. We have to take the value of y that we found and plug it in one of the two equations. Which one should we plug it in? The second one. I would have done the same thing. Two times 0 is 0, so x plus 0 equals 1, which would imply x is 1. Good. Okay, so this is a problem where it doesn't matter. We have to multiply one of the equations by some number, period, or else they can't solve. So either I can eliminate x or I can eliminate y. It is a matter of choice. I am going to eliminate x. To eliminate x, I need to have a 5x there. How do I get 5x there? Multiply by 5 on both sides. Seven times 5, 35y, would equal to 22 times 5, that is 110. Good. Subtract 5x and 5x would go away. You will have negative 34y, and that would equal to 8 minus 110, which is negative 102. So what is y? Negatives would go away. 102 divided by 34. So would they get cancelled? By what? 3. So the value of y is 3. Now that we have 3, we can plug that 3 in one of the two equations. Which one do you want to plug it in? Second one. X plus 7 times 3 equals 22. X would be 22. Oops. 21. 7 times 3 is 21. Move that 21 to the other side. 22 minus 21, which will give you x to be 1. X is 1, y is 3. The solution is 1,3. And 1,3 simply means a point, xy pair, and that is the point where these two lines do what? Intersect. Okay.